Thank you, everybody. Just a few things in advance. I'm supposed to talk for 45 minutes, and there's no way that's going to happen. So if you guys want to help me pad it out by asking questions. It's going to be very math and sports heavy. So if there's something I mentioned that you don't understand, perhaps on the math side or on the sports side, just let me know. Feel free to stop me. I really don't mind. Yeah, and let's get started. So a little bit about me. I founded NumberFire in 2010 after being on Who Wants to Be a Millionaire. It's on YouTube, so if you want to go look it up. There's a good clip of me dancing with Regis, and if you've ever seen Regis Philbin, he's like 5'2", and I'm 6'6". So there's some interesting sort of contrast between me and Regis. My background's in computer science and design. I went to Carnegie Mellon in Pittsburgh, grew up in Pittsburgh, born in Pittsburgh, complete Yinzer all the way through, Steelers, Penguins, that whole deal. I worked for a big company right out of college, Yahoo. There's probably a reason why I'm not there anymore. I'm sure you can probably figure that out. And small work market, which is a labor market startup here, and SpunCell, which is an ad tech company. Scorpio, like long walks on the beach, and all that. Okay, so NumberFire. So NumberFire is the sort of VC pitch that I give is that it's the next generation sports analytics platform. And that's super buzzwordy. That's like very VC pitch heavy. So basically what it is it's a big data platform that helps anyone who wants to know more about sports understand it at a higher level. So if you're familiar with Moneyball, there's sort of this big revolution going on in sports towards data-driven analysis. Simply because so much of sports is data. Everything that happens in a sporting match, whether it's a rebound, a completed pass, a strikeout, those are all recorded. Those are parts of the game. But when you go to ESPN.com, you go to Yahoo Sports, you go to any sort of the qualitative news media sites, they don't really do much on the information. They kind of just tell you, okay, this is what happened. They're counting up a rundown of what happened in the game. And that doesn't really value the data correctly. If you have the data and you have the infrastructure to do something with it, it kind of does the readers a disservice to not do more with it. So that's sort of the idea behind NumberFire. So that the two sides of what we do at NumberFire, and believe me, this is the only slide on NumberFire. I'm one of the CEOs who hates talking about his own company, so this is all you're going to hear about it. First part of it is sort of understanding how good these teams of players actually are. So when it comes to statistics, they can be very misleading. For example, if you're familiar with the Seattle Seahawks, who just should have won the Super Bowl but didn't, they've got a very strong defense. So if a quarterback throws for 300 yards against the Seattle Seahawks, that means more than throwing for 300 yards against a weak defense like the Browns. But if all you're looking at was number 300, then you wouldn't necessarily understand the difference between the two. So once you have an understanding of how good those teams and players are, you can use that to then project out what's going to happen in the future. So one thing I always say around NumberFire is that what's already happened is interesting, but what's going to happen next is much more interesting. So if you know what's going to happen next with some level of predictability, that's got manifestations in fantasy football, the teams themselves, the leagues themselves, broadcasting, and so on. And so I'll go into a bunch of details about that later. We work with ESPN, NFL, Cantor Fitzgerald, which is a large sort of sports betting conglomerate, DraftKings, which is a fantasy sports company, and consumers like you guys. So if you guys are sports fans or played fantasy sports or just want to know more about the teams you love, I would love it if you checked it out. I'd love it even more if you liked it and told your friends, but I can only ask so much. All right, so what are analytics? So when I say analytics, basically what I mean is it's sort of a buzzwordy term that means sort of advanced statistics is probably the best way to think about it. So if you think of statistics as, again, just a count of what happened, analytics are different insights that are brought upon by looking at information in different lights and different contexts. So in the specific sports context, analytics is generally the process of taking large amounts of data and mining it and figuring out, okay, in what situations is this player best suited to do well, or this team best suited to do well. It's really just a function of data analysis. And it's generally sort of conflated with big data, and as sort of like a editorial side, I hate that term. I think it absolutely sucks. Like, big data is mostly used by people who don't understand how big data needs to be. Like, my criteria for big data is like hundreds of millions of rows, like sentiment analysis on Twitter. That's big data. What we do isn't really big data. It's data analysis. It's a different story. But yeah, so it's generally conflated with big data. So if you've seen different kinds of presentations on big data and data analysis, analytics in this context, generally, that's what it means. Okay, so yeah, so kind of what I was saying earlier, the main difference between analytics and statistics are statistics in the sports context are just counts of what happened. You're counting up passing yards, you're counting up hits, you're counting up rebounds. Those are just counting statistics, and they're fundamentally flawed for reasons which I described. In the past 10 years or so, there's been a real revolution within sports to define new and advanced statistics, one of which is called WAR, which is wins above replacement. So wins above replacement essentially means that a replacement player in a league is someone who's average, who's perfectly average. He's right in the mean of ability across his league. So in the case of basketball, you've got someone like LeBron James. He might have a plus 15 wins above average, meaning that if you take an average team with fully average players and suddenly put LeBron on it, that team's going to win 15 more games than it otherwise would. So it's analytics that bring about those kind of comparisons, which allow you, if you're a team, to make smarter decisions and so on. So if you've seen Moneyball, generally that's what it means. I mean, obviously the movie kind of watered it down, but that's the gist of what we're going towards. And I'm very similar to Brad Pitt in a lot of ways, as I'm sure you can imagine. Analytics in the real world, you can apply it to a bunch of different industries. Finance, if anyone here has ever worked on Wall Street, I'm sure you're familiar with statistics, beta and gamma and kappa. Basically different ways of valuing an equity versus traditional values like P/E ratio and so on. Real estate, I would love for you to go on Zillow sometime and look up what your childhood home's value is. I mean, it's kind of interesting to me that they do that. It's, they use different factors to evaluate homes on a apples-to-apples level, which I think is kind of interesting. Startups all the time. I'm sure people here have done a bunch of data-driven optimizations using Optimizely or whatever. Heap is another good one. With banking, credit scores are an example of analytics. Retail, any kind of customer segmentation, that's all examples of analytics outside of the sports context. Now, within sports, the best way to do it is sort of use analytics to decide, all right, who do I draft? Who do I start? What plays do I run? What plays shouldn't I run? So, a great example of this is the Super Bowl. How many of you guys saw the Super Bowl? That was like the slowest hand raise ever. It went from like 10% to like 75%, and it was like, well, I don't know. So the second to last play of the game was the one where Seattle was supposed to run the ball, but they didn't. So you would think that if they were using analytics, they would generally see that, well, they probably should have ran the ball. Well, it turns out it actually wasn't as terrible of a play as you thought it was. Basically, we ran the numbers, that's what we do. When you run the ball in that situation, you've got an expected points of about 2.7 to 2.8 points, but passing the ball is about 3.1. So in terms of strict apples-to-apples comparison, the pass was actually the better play. The problem was that the pass, basically when you pass the ball, there's three outcomes can happen and two are bad: incompletion or a turnover. And so it just so happened that the risk of passing the ball was so high that the conservative play in that time was to run it. But analytics can help you figure out those decisions in real time. On the sort of the consumer-facing side, if you're a writer, a beat writer, newspaper guy, a broadcaster, you can write smarter, more engaging articles, do lots of cool stuff with broadcast, which we'll get into later, kind of moving real-time analytics towards the broadcast. And of course, fantasy players, March Madness, things like that. Any kind of games you're in give you a huge advantage, and use NumberFire for that. Okay, so the main thing I want to talk about in terms of how we do it is something called the Markov chain. So does anyone know what a Markov chain is here? This would be like the tell of a true nerd if someone knows what a Markov chain is. I was hoping, nobody. Damn, I was really hoping there was. Okay, so a Markov chain is a mathematical concept, a finite series of independent events in which states are changed irrevertibly over time. So a Markov chain can be applied to any sort of, actually here's a good example. So this is a Markov chain. So this is where I grew up in Pittsburgh. This is like the North Hills of Pittsburgh. This is where I went to school. All right, so basically, if you're familiar with a graph theory has basically some number of nodes, and each one of those nodes has a weight to it. And so anytime you're driving somewhere, that's essentially a graph, where each one of these nodes is where you make a turn, and the time at which it takes from get to node is the weight of that node. So a Markov chain is essentially, like I said, it's a chain of events which are independent, but the state changes over time. So you can also apply that in the sports context to a possession in basketball, a series in football, in that after each one of those things happen, the outcome potentially changes. And so if you're going down the field in football, let's say it's 1st and 10 in the 50-yard line, you've got an expected points on that drive of like 3. But then you throw the ball 30 yards down the field, now it's a 1st and 10 in the 20, now your expected points goes from 3 to 5. And the Markov chain represents that series as a mathematical sort of indication of what happens. And so as you iterate over that Markov chain, it allows you to understand what happened in relation to other events historically and so on. So I'll give you a specific example. And there's a typo here. How did Aaron, whoops, so let's say I want to know how Aaron Rodgers was going to do in the NFC Championship. This is an older deck. This happened like 2 months ago. But let's say I travel back in time and I wanted to know how Aaron Rodgers was going to do in the NFC Championship. That's a very nebulous, intangible question to ask, right? Like, how do you even start to sort of understand how to grasp that problem? So you can go to like ESPN.com and see like these visualizations of information, but you can't really glean much information about it. Again, these are mostly just recaps of what happened. Or you can go and read articles, and you'll be hit with fantastic insights like this. I just don't like it this week, as simple as that. And as someone who deals in math and data and science, like this is sort of like the worst crap ever. It just drives me crazy. So because the numbers are there, let's kind of do something with it. So the first part of sort of the advanced stats life cycle is understanding the concept or the context of stats. So in this specific play, Green Bay has the ball on the Dallas 45-yard line. It's 3rd and 9. Now on this play, Aaron Rodgers passed the ball down the middle to Randall Cobb for 12 yards. Now the situation in the game changes from 3rd and 9 on the 45 to 1st and 10 on the 33. So going back to our Markov chain, I'll go over here. So going back to our Markov chain, what happens is the expected points in that drive now goes from 1.41 to 3.56. Because if we didn't convert that play, the most likely outcome would have been punt. But now that he's on the 33 of the first down, now the most likely outcome is probably a field goal. So that represents a plus 2.15 net expectancy, which is the delta between the 3.5 and the 1.4. So that tells us that Aaron Rodgers literally created 2.15 points for his team. Then moving forward, if I wanted to know, all right, how is Aaron Rodgers going to do in tomorrow's game? So I'll take Aaron Rodgers' efficiency rating over the course of the year. And again, this efficiency rating is different than his QB rating, his passing yards. This is an example of the analytics I was talking about earlier. So we'll take Aaron Rodgers, and we'll compare him to people historically which are statistically similar in his analytics. In this case, he's 99.31% similar to Phillip Rivers. He's 97% similar to Dan Marino, and so on. And so we're basically taking a giant union of 3 data sets. All the players similar to Aaron Rodgers, all the teams similar offensively to the Packers, all the defenses similar in efficiency to the Cowboys, and then finding the closest match in that union data set, and then coming up with a highly scientific, highly analytic projection of what's going to happen. So in case anyone's curious, which you're probably not, this is how it works. Data goes in, we do stuff with it, we spit it out. I won't necessarily blame you with that. But as far as the UX side of it, so let's kind of go into the problems of being a data company from a UX perspective. So the first problem is, how do you convey enough information that it communicates certainty but not overdo it? So there's plenty of ways to just spit data out in a page, but you can't necessarily expect someone to mine any kind of information from that kind of UI. So the way we generally approach it at NumberFire as far as solving that problem is to highlight the most important data and use visual cues to indicate relative importance. So on this page, wow, that really washes out. Okay, this is supposed to be a brighter yellow and not this kind of like vomit yellow going on. But yeah, so the idea is that if someone wants to go to this page, they can indicate, most likely for our use case, someone most likely just wants to know, how is Robert Griffin going to do this week? So obviously we highlight it. And as far as the next level of information, okay, what's the second most important thing on this page? It's probably the matchup information, which is why it's a little larger, more padding on the cells, and so on. So, when it comes to data in this context and how to lay it out, we've essentially gone the color and relative size and bold UX approach. along with some user testing to kind of generally understand, all right, this is what people care about, this is the way we should lay it out, and so on. So, a big part of that is sort of understanding use cases. So anyone, yes, Matt.
Hey, I'm curious about the user testing you did talk about. What was important to people?
Yeah.
How do you frame those tests? What do they look like when you bring into it?
Right, okay. So I'm a huge fan of the opposite of in-person user testing. Just because you bring someone in and do user testing in person, it's a small sample size. There's a whole bunch of different human biases that happen. You can lead people on in questions they didn't otherwise think you're going to. So we have a pretty robust testing mechanism in place. It is a lot of heap, a lot of optimizedly, just constant multivariate A/B testing and so on. And eventually, you look at enough pathways of how someone goes from a landing page to their destination page or so on, and you get to understand different cohorts of what people want to do. So we saw that, generally speaking, when someone went to the RG3 page or the Brett Favre page or whatever player page, more often than not, the next page they went to was fantasy football related. So we kind of generally made the assumption that based on that, people want to know fantasy information. If you want to know fantasy football specific information, you probably want to know this information first, and that stuff second, and that stuff third, with all this other correlated stuff being nowhere near as important. So yeah, so like I said, you want to understand use cases the best as you can. The best way to do that in my mind is, like I just said, use things like heap and optimizely and different kind of testing mechanisms to understand the cohorts of your users. The side note to that is that I hate personas. So going back to my days in the design world, I would see like a ton of like really slow overhead stuff like personas and wireframes and like just I'm very much of the opinion that you need to build and test and not sit around and plan. So this is my personal opinion, but like if someone tries to suck you into getting a lot of personas done, I say it's a waste of time. But my opinion. Anyway, so
analytics, right? Because you have analytics.
yeah, well, yeah.
If you didn't have analytics or anything like that, you have to know personas.
Yeah, yes. I mean, guess what I'm driving at is I'm very much of the opinion that anytime you're doing things in a qualitative way, like a persona or like an in-person user testing, it's just not a big enough sample size.
I agree with
Yeah.
you.
Yeah.
It's a thing of the past.
Yeah. Yes. Okay, so yes, just like Flash. That's correct. In Cold Fusion and PHP to a certain extent. Okay, so going back to this, so like this is another example of the prioritization of information. So this is a game projections page. This is how the Knicks and Magic are going to do tonight. We think the Magic are going to win by 2 points because the Knicks are terrible. And so anyone on this page generally just wants to know who's going to win and by how much. So again, we use the highlighting, different kinds of coloring and bracketing of information. In this case, it's a little more horizontal than the other one was. The other one was sort of focused right here. This one's across the top. You can't really tell, but there's supposed to be like a light blue background back behind this, which gives it some contrast and emphasis, but you can't see it here. But yeah, so the idea is that, again, this is obvious, but I think a lot of people fall into the trap of just, throw data on a page and see what happens. You really have to be as diligent as possible to, figure out what the most valuable information is to your user and then display it in the best way. So yeah, so again, go to sort of the second problem of UX and data from my perspective. How do you present all options without overwhelming the reader? So in our case, the best way to do it is to present as many filtering and sorting options as possible. So in our case, this is a big page of our basketball projections for the night. Now again, unless you had some ability to filter this or sort this, you may as well just have an Excel spreadsheet. Except the Excel spreadsheet can filter for you. In this sense, like all the column headings are sorted. This is sortable. You can filter by position, filter by site if you're playing daily fantasy. And again, it's an obvious point, but I do want to belabor it to a certain extent. You really have to figure out, okay, what's the use case for this? How do I filter it? How do I sort it? How do I drill it down from some really top-end view into the smallest atom of information that's useful to my user? And it can be a laborious thing from a UX perspective to do that, especially when you're dealing with large amounts of data, because kind of real-time AJAX filtering of megabytes of JSON response information, that's not easy. But it's kind of what you have to do. I mean, it's without it, you're just kind of leaving your user to to be able to parse it from the immediate recognition of the page, which is just not a good thing to do. And this is the mobile version of the same site. On the top, we have perhaps a little more obvious sorting and searching functionality. Mobile is yeah, go ahead.
Sorry.
No, go ahead.
Curious how off the projections are, or the differences between the projections and the player's actual averages are. Obviously, it's weighted based on the opponent.
Yes.
But how close are they?
Yeah, I mean, so it's going to be dependent on sport, dependent on the player. The one sort of marketing thing that we do trot out a lot is that if you use us to play fantasy football, you're 47% more likely to win your league than without us. So that's, a pretty good marketing bullet to have. We've accurately predicted the winner of the NCAA men's basketball championship like 6 straight years, which has been pretty good. Yeah, so I can't give a general answer. It depends on the sport, it depends on the player. But yeah, I mean, anytime you have some sort of data algorithm system, it's going to be better than some qualitative system just across the board. For the same reason why a computer is going to pick a stock better than like most people just picking them in a room with a dartboard or something like that.
This is just an isolated
Yeah.
question. It's more like about branding.
Sure.
Why fire?
Oh, okay. You're gonna love this. This is okay. So I had no idea how to name the company when I started it. So I basically wrote a PHP script, which I had one array of prefixes, like number, sport, football, whatever. And then a second array of suffixes, like all Web 2.0 suffixes, like ent, ly, all that stuff. And so basically I wrote a script that essentially matched up each prefix with each suffix and then made a call out to internik to see whether or not the .com was available. And out of 17,000 iterations, whatever it was, only one .com was available. It was NumberFire.com. So that's how I did it. So in case you're curious, I actually hated the name. When I first started, I hated the name, and now I actually kind of like it. It's grown on me in a weird way. It's like 5 years ago. Yeah. So I hated it, but now I like it. It's not bad. Yeah, good.
So just going over this for you specifically. So
Yeah.
you use colors and then you use size to sort of highlight
Right.
points.
Yes.
Is that
Oh yeah. So what you can't tell is there's actually like a light yellow thing down here, which indicates that is the active sorting column.
is that part of the process?
Correct.
That's most important to highlight out.
Yeah. So like when you load this the first time through, without clicking on something, points is pre-sorted because that's probably the most thing when basketball fans think of, okay, what's the best player? They think points first. So it's pre-sorted for points. But if I were to click on rebounds, then that goes normal, that goes bold, and the yellow column moves from here to here. All right. So part number 3, how do you solve for different use cases within the same data set? So the solution to that, generally speaking, is to build dashboard views as well as drill-down views. So you want to allow for as much customer segmentation as possible within the same screen. If there's a way for you to serve both the casual user and the hardcore user within the same screen without having to bifurcate the experience of sending one person this way and another person that way, that's just generally a good idea. If you can, on top of your data, have some sort of qualitative layer, not in the sense of having someone go in and change around the data, but add some editorial context to it, some just some color to it, to humanize some of the data. So there's 2 really cool companies that are out there. One is called Narrative Science. The other one's called Automated Insights. And basically what they do is they take in and ingest data sets and spit out natural language readouts of that data. So you can imagine plugging in your Google Analytics to a company like that, and then every morning they send you 5 or 6 highlights of your last night's traffic, or your 5 or 6 most actionable things for the next day, and so on. So when you have that qualitative layer, it sort of removes the onus from you from figuring out how to build the best dashboard, because you can use natural language to figure out what the insights are, and so on. So how we solve this in this case is, this is our homepage, and wow, it's so washed out, it's crazy. So if you just want to kind of like get the idea of, have someone kind of tell you what the insights are, we'll have an article for that. So in this case, we're talking about how Steph Curry is going to score like 80 points tonight against the Sixers. But if you want to like really dig into the information, we have this widget over here, which essentially has the same information. This is just the data, which you can click through over here and get the really strong drill down. So there's really three levels of information hierarchy here. There's the hardcore drill down, the widget view, which is really the overview of what's going on, and the editorial layer on top of it, which is just the equivalent of a dashboard, just sort of human edited. And there's other ways you can do it too. In this case, I was spitting out things via Twitter and via widget on, I think that was the Atlantic. So if you remember during the World Cup when the US won the game against, I think it was Ghana, we immediately, the second after that game happened, we had real-time advancement odds out of the group. Germany, pretty much 100%, USA 80, and so on. And so, again, that qualitative layer allows you to do a lot of cool things from a marketing perspective, like social media, like content marketing, like widgets that go on other sites, and so on. Cool. So, problem number 4. How do you give your users access to the data? Is that even a good idea? So this one, there's probably going to be a lot of debate about. I mean, I don't have a really great answer for this. If you're familiar with this screen is the bane of my existence, or it was for many years. This is PHP MindMin. So PHP MindMin is basically a web interface for a SQL database, and it basically allows you to run any kind of query you want, from a simple select to, creating a whole database. So if you look at this, I mean, it's like an incredibly complex system because it has to fill the needs of a DBA, right? So if you're a DBA, you have to be able to run a bunch of queries, and this is a web interface for it. From my perspective, like this is kind of more what we have to do, which is, we work with writers, beat writers, broadcast people, and so on. We want them to be able to take our data, then spit it out via their articles or whatever they want to do with it. So we have a system similar to PHP MindMin, which allows you to run a subselect of certain queries and then basically get the information and then embed it either with some natural language text or via an iframe widget or so on. This is how we do it. This example of the iframe widget on Bleach Report. I don't know what the right answer is to this because, there's money in data and there's money in having it, and allowing people to go in and do stuff with it may not kind of fit your business, what you want to do with it. So again, I don't have a strong recommendation either way for this one. This is what we do. And if you do this, I strongly avoid not doing that because that's, awful. Okay, and now the most important aspect of data is, in my mind, time sensitivity. That is the most important thing. I care about that even more than I care about accuracy. Because I don't want to say you'd rather be fast than be right, but if you're going to have to kind of choose one, you want to be fast. Because the data is being commoditized to a point where, speed is everything. Latency is everything. The ability to ingest the information faster, spit it out faster, to export it faster, that's sort of where things are going, just on the basis of how the technology with like Hadoop and everything else is making it easier for companies to do what you're doing. So in this context, this is kind of where the cool stuff is from my perspective. So this is something we're doing with NBC, sort of going back to what I was saying earlier with the NFL context. So if you're watching a game in real time, we're able to basically tell you at any given moment who's most likely to win, what likelihood for first down is, how likely a certain play is involving a certain player, and so on. So, without one, the tech infrastructure to be able to handle that stuff, and two, without sort of the commitment to speed, you can't really do that. But it's that kind of speed that really sits around the marketplace. So for those of you who are sort of considering database businesses, in the conversations I've had with people who, decide whether to do partnerships or what to buy and so on, speed is almost overwhelmingly the first thing they care about. Because in this case, if I wait 15 seconds to spit this out, play's already happened. It's already dead. I mean, the information won't be useful after that 15 seconds. So I care about speed more than anything. And if anyone wants to have a tech conversation about how we do that, I'm more than happy to, but probably for the...
That's why I was asking about the name Fire.
Yeah.
Database Firebase.
That's the first time I've ever made that connection. Wow.
Firebase, it's the same, it's like quick data.
Right.
It's the future, basically. It's the back end has a service.
Correct.
It's going to take over.
Yeah.
A whole bunch of back ends are going to.
Right. So, looking back for a second. So this screen actually, right here is actually kind of a misnomer, right? Like, behind this screen is probably like 20 or 25 different API sets running back to our database. So I'm a big proponent of what's called eating your own dog food, which is if you're going to build an API for other people, you should build it for yourself as well. So this is actually running off of the NumberFire API, just as ESPN is running off the API, just as the MEC broadcast is running off of our API. So, again, in the data business, your best bet is to sort of build the infrastructure the best you can first, not necessarily worry about how your homepage looks or how your, how this or that looks. Build your API first, build the infrastructure, build the foundation of the house, and then build layers on top of it. Because once you go back and let's say you mess it up, right? The technical debt of going back and changing around that infrastructure layer is just way, way too hard. So, for what it's worth. So I lost my place. And so this is kind of another view of what this was specifically for the Super Bowl. So at the point in which Seattle should have ran the ball, this is actually 2 or 3 plays before that. As they were driving down the field, at that point, next play was 85% likely pass. The most likely drive outcome was 42% loss of downs and so on. So it's just another view of this inside of an iPhone platform. And I have reached the end of my presentation at 31 minutes. That's not bad. Yeah. Yes, go ahead.
So is this data, this information making its way into gameplay?
Yes. So we actually, I hate to talk about my company so much because I know you guys don't care. But yeah, so we work with the Jazz a little bit. In basketball, we work with the Jaguars a little bit. It does affect specific play selection a little bit. There's still some resistance, especially in football, because football is kind of more like the old jocks, like what do these nerds know about sports kind of mentality. But it is creeping in, which is why you see a lot more teams going for it on fourth down and things like that. Like it's getting there. It's definitely changed basketball. Basketball has changed in the past 5 years dramatically. I mean, you see teams no longer taking long 2-point shots because there's no reason to. It's turned into very much like a 3-pointer and dunk layup league because those are the high value shots. And so, yeah, it's creeping in, not as much as I would like, but I would say in the past 3 or 4 years, it's made some serious penetration for sure. Yeah.
So, with background is Charles Barkley.
Yeah. Dude, he's so wrong. I can't believe he said that.
But you're gearing most of your business towards fan perspectives.
Yes.
How would your UI be different if you're sitting in Daryl Morey's?
Right.
And what's the presentation that you're looking at?
Yeah, that's a good question. I mean, unlike most companies, in our space, we're unusually more consumer-driven than most, right? There's like Stats Inc., there's Bloomberg, which is more B2B companies. They build almost like iPad applications where the coaches have it courtside, and they'll build out like different kind of like really robust-looking like dashboards, pretty similar to I lost it. Well, you know what I'm talking about. Like they build out dashboards that essentially are like intranets for someone like Daryl Morey to go and run queries off of. So because you're talking about dealing with 10 potential users versus 10 million users, it's probably much more customized. Like Daryl Morey probably went to some client and said, all right, I need this report. I need that report. I need you to push this to me. Whereas for us, we really need to like figure out what our users are doing and run those analyses. Whereas on the B2B side, it's basically just like custom dev work. Yeah. Sure. Yeah. So, on the base level, it's pretty much a LAMP stack. So Linux, Apache, MySQL, PHP. The actual regression in numbers is run through Python, which connects to a Scala script, which connects to a series of R scripts, which ingest the information, take it, do stuff to it, and then spit it out through the pipelines all the way to the database, which is the MySQL database. There's other stuff going on, like there's like the R and it like runs through some MapReduce stuff. The the site itself has different kind of memcache layers and so on. But that's the gist of it. I mean, is that deep enough? I mean, I can go more into it if you want. Oh, this one. Yeah, okay, I can walk through it. All right. So what happens is we get information in pretty much constantly. So we get live data in during a game. In the pregame, we'll ingest information like weather, injury reports, and so on. Post-game, we'll ingest the basic statistics of what goes on. So that hits our database and essentially kicks off a series of cron jobs which go over that data. So going back to my example of the Aaron Rodgers example, what it does is it reads in that information, iterates over it, does different kinds of regression modeling, some neural networking, the similarity scoring algorithm, which I mentioned, the machine learning, which is sort of understanding a team's tendencies over time, and the inductive logic of just sort of putting it all together. So data goes in, kicks off cron jobs, which run this. The running of this mostly sits in the R and Scala layer, but then it gets pushed into here, which is really where the presentation layer is. So if this is sort of the model, this is getting into the controllers here, and this is the view here. So the view is essentially sitting on top of our API, which is what this is, and then spits it out to our website or our partners, depending on the context which we need it. Anything else? Yeah, go ahead.
I know on your site, so you cover 4 professional sports.
Yes.
Basketball.
Yep. Right.
I saw obviously other companies doing other things, NASCAR.
Right.
Like that.
So the short answer is there are some sports which are a lot easier than others, right? So basketball and baseball are the easiest. Football is very hard. NASCAR is probably just about impossible because there's so many different colluding variables that it's very hard to assign importance to any one event. So for us to do what we do, going back to sort of the data layer, like we need a very, very high fidelity data feed for us to do what we do. Like we have to know, for example, when it says Jay Jones, it's actually Julio Jones, not James Jones, not John Jones, but Julio Jones. So in a lot of the sports where perhaps there's not as much consumer interest, those data feeds either don't exist or are prohibitively expensive for us doing that. So we've essentially decided that we'll go after the main consumer sports first because we can build out the fantasy aspect and the editorial aspect and so on with the idea that if we got to a large enough scale, maybe some NASCAR team would be like, oh, that's cool, I wonder what they can do. So we've been approached on sort of like one-off things on everything from predicting movie grosses to horse racing. One person asked us if we could predict how likely he was to win a seat on his school board. It was like, so I mean, there's a lot of applications for it, which is sort of why we built the API layer the way we have. From a long-term perspective, if you're all VCs, part of my pitch would be that in 5 years, there could be NumberFire finance, NumberFire education, NumberFire politics, and because we architected the stack the way we did, it's essentially a trivial application to move on to the next industry. We wouldn't have to reinvent the wheels because the architecture for moving the data into place and regressing it and so on is already there. Cool. All right. Yeah, go ahead. You're next. Don't worry. Go ahead. I don't know, to be honest with you. I would guess no. You know what? Maybe. So the Markov chain, the way I think about it, is like a very discrete event. One possession, one series, one at-bat. But I guess you could look at boxing as like a round is one of those series. But yeah, I mean, I guess it could. But I wouldn't even know where to start with that, to be honest with you. So that's a non-answer, I know, but that maybe. Yeah, no. I mean, there's definitely models you can apply to those sports for sure. I mean, there are people who professionally predict the outcomes of boxing matches and MMA matches and so on. I don't know for sure if they're using something analogous to a Markov chain to do that kind of analysis. That I don't know. My guess is that they're probably doing your basic similarity scoring to do that without really understanding what makes a boxer work in what kind of situations. Maybe they're doing some kind of video analysis, but I would be surprised if they're doing any kind of Markov chain stuff for those sports. It'd be surprising. I mean, it'd be cool if they were. I'd like to know about it, but I'd be surprised if they were. Yep.
Yes, you talked about the Seattle interception.
Yeah.
And you talk about how the pass was actually not that.
Right, right.
So when it comes to conclusion, do you consider all the Seattle options, say Marshawn Lynch,
Yeah.
probably getting a yard?
Correct,
Or
yeah.
do you consider it also as well, like, what is the difference?
Yes, yeah.
You bring in all of those factors.
Right. It's
What factors?
yeah. So there's a very rigorous level of back testing that goes on as well. So we know, for example, that weather, for example, is way overrated. So like weather, for the most part, for an elite team, really doesn't matter. So the best way you can do that is, looking at football historically, you got 80, 90 years of plays, right? And there's probably 500 to 600 instances of a team like Seattle in a situation like they were in. And so you look at it and say, all right, well, this team ran it, scored a touchdown. This team passed it, scored a touchdown. And you look at it over time and you adjust for era, adjust for the skill sets of the individual players involved, and you generally understand at a large enough scale what the best plays are. So it's really just a matter of data. I mean, if you have the data and understand what to do with it, then it becomes just how many different kinds of iterations, how big is your sample size. I mean, if there's only one comparable for that situation, then it's kind of like, all right, well, who knows what they should have done. But because we looked into it and saw there were 600, 700, 800 similar plays just like that, we feel a little more confident in saying that the pass wasn't as bad as it turned out to be.
Personnel couldn't range from terrible running back to passing back. Pretty much a broad range.
Right. So like maybe 10 years ago, there was a similar play involving, I don't know, Terrell Davis, right? Terrell Davis has a different skill set than Marshawn Lynch. We would know, for example, that Terrell Davis doesn't do as well in short yard situations than Marshawn Lynch does. So if 10 years ago, if the Broncos decided to pass, that's a more sensible play given their personnel versus Marshawn Lynch would be given his skill set for the Seahawks. So we adjust for all that. Yeah.
Well, just going on that, where you did the Aaron Rodgers comparison
Yeah.
to other people too.
Right.
And in terms of passing stacks, correct the Marino,
Yeah.
Phillip Rivers.
Right.
But one thing with Aaron Rodgers and even with Russell Wilson is their mobility.
Right.
And Aaron Rodgers extended plays.
Yeah.
So with Russell Wilson, where you have a running back like Marshawn Lynch and Russell Wilson's mobility, that changes the factor in terms of the success rate. I think
Sure, absolutely.
that you're going to run.
Yep.
And then given New England, where you have the backs that you have, the Revis and so forth.
Yeah.
Again, the numbers are higher in most cases, in most data sets.
Sure.
But the type of personnel.
Yeah, no, it's absolutely true that if the Seahawks were playing a team other than the Patriots, pass would have been a better play. I don't know to what extent it would be because we didn't run that, but yes, I mean, when you're saying something as seemingly simple as they should have ran the ball, they should have passed the ball, there's actually millions of data points underneath that. Everything from, okay, well, this is what Russell Wilson can do. This is what Darrelle Revis can do, to the interplay between all those items. So like, what's the connection between Russell Wilson and Marshawn Lynch? Or how does the comparably weak Seattle receivers affect Russell Wilson's passing ability? I mean, you got to factor all that in. So, which is kind of why from going back to the infrastructure perspective, you really have to have like a really strong tech house to be able to do that sort of thing. Yeah, good.
How many data points are you taking into consideration for that play?
That play? In the millions, probably. I don't have like a specific number, but yeah, probably in the millions. Yeah.
What league has the best data, and how do you get that raw data?
Which league serves us the best data? So NBA has the best data. So NBA partnered with a company called Stats Inc. For a service called SportView. Sport View is essentially like 16 cameras which are set up courtside, which have like frame rates of millionths of a second that look at every single thing going on in a court in like an XYZ space. So like if I'm here, I'm at like coordinate 2 and 5 and 6, 6. And so when you're calculating all the information millionths of a second at a time, you're for each game creating terabytes worth of information, like just such a large amount that it's almost impossible to do stuff with it. So in that sense, in like the sheer bulk of it, NBA has the best information, but it's very hard to parse it into something real or something valuable. The flip side of that is like Major League Baseball, in that there isn't really a lot of information they can give you which is valuable, but the stuff they do give you is intensely predictive of what's going to happen. I mean, there's a reason why this entire revolution started with baseball, because baseball is easiest to model, baseball is easiest to predict. So they don't need to give you as high fidelity of a data feed to do stuff cool with it, which is why like the revolution started in baseball 30 years ago and is just getting to NFL and NBA now. Jeez, okay. Let's go, you, right there.
So I'd like to know how are you automating your live data feeds?
Okay.
It's like you're spitting out information out in real time.
Yeah.
Before the play happens or as the play happens. And I'm assuming that most of that is based on past information.
Yes.
How are you integrating live information? How is that automated?
Yeah, so they were like a cottage industry of companies which do nothing but serve live data to companies like us. So it's as simple as someone sitting at the game with an iPad putting stuff in, to as robust as the leagues themselves providing it as well. So it's really an automated process in the sense that they'll send us essentially like an XML feed or a JSON feed. It hits our application, goes to the database, it gets regressed, it gets modeled, and gets pushed to the front end through our API to the app or to our partners. That entire life cycle takes 2 to 3 seconds, which is why you really need to find a data provider which is really, really high quality, or else it won't work at all. Which is why the companies that do provide that information, the StatSyncs of the world, provide. I mean, it's very expensive to get that information. It's almost prohibitively expensive for a startup to get it. But yeah, I mean, that's the long and short of it. I can get into more of it if you want, but that's kind of the general of it. Yeah, good.
So, curious if your focus is more on getting teams on board to use your product or fantasy users, and what you're doing to,
Yeah.
I guess, increase your user base.
Yeah, it's almost all consumers. Really early in our company's being around, we had a meeting with the GM of the Yankees, Brian Cashman. And we get up there, and he's just like, so, what are you guys working on? And we're like, okay, well, we're doing this and this and this and this and this. And he was like, okay, that's cool. How do you guys feel with just working with me and nobody else? And so when you think of the market size for teams, there's 119 professional teams. So you might think there's 190 teams to work with. But no, the real number is 4, because you can only work with one team in one league. No team will let you sign a non-exclusive contract such that you can work with the Red Sox and the Yankees, because they're worried that you'll tell them what the other is doing and so on. So the market for working professionally with teams, 1, it's a long sales cycle. 2, it's just not a big enough market. So we decided to go right after consumers, starting in fantasy sports and branching out into things like March Madness and so on. The best way for us to sort of gain a large user base is really through the content, right? So when you have content that sits on top of data, that allows you to do so much more marketing-wise than just the data. With a piece of content, you put on social media, you put it on a content marketing platform like an Outbrain or Taboola, you syndicate it out to beat writers, to blogs, whatever. That's a much more effective way of marketing information than just sending out, a spreadsheet or XML or whatever it is. So it's really the qualitative layer on top of it which allows you to market more effectively. Yeah, good.
So following up on that,
Yep.
how many teams are all these teams building their own backend?
More often than not, the teams themselves just work with other companies. I mean, there are some teams that do it all themselves because they're intensely secretive of their stuff. Some teams just have like basic deals worked out with Stats Inc. or Elias or Bloomberg or something like that. There's really no one-size-fits-all solution for each one of these teams. It's kind of basically how paranoid they are is probably the best way to say it. So yeah, I mean, I've seen everything from the Rockets, who probably have 10 or 15 people on staff, employees, doing this sort of thing. And there's other teams like the Buffalo Bills who couldn't care less. They have no interest in it, think it's dumb, and maybe that's why they went 4-12, you know? I don't know. Anything else? Yeah, go ahead.
This is more like a UI, and you have a tab navigation on your mobile version.
Yeah.
And you have the home, you have the user.
Yeah.
Then you have a drop-down menu with 13 items.
Yeah.
Only 6 of them, 7 can give me, access to, okay, sign up.
Yeah.
Like, why don't you guys do something that, if I'm not a user, you can make this, that it's not active, and it's actually encourage me
Yes.
sign in instead of giving me all this.
That is a
UI, UX thing,
Yeah.
but it doesn't really work.
that is a conversation I often have with our marketing guy. That's the app.
It's a waste of time. I can drop this app in a minute. And
Yeah.
because of that UI.
Yeah, well, yeah, I mean, I would say that the app is probably not as much of a concern.
It's really long. I have 15 items, and only 3 of them are active. Most of them, they just send me to, oh, you need to sign in.
Really?
You need to sign in. Yeah.
We'll have that.
So it's kind of like a waste of time.
Yeah.
I can drop this in a second.
I mean,
Just saying.
yeah, no.
The UI architecture, UX architecture needs to be a little bit more enhanced.
I would absolutely agree. Yeah, I mean, the iPhone is. We were dumb to not go mobile first when we started, which has sort of worked against us for sure. So we've been playing catch up on mobile for way too long. So yes, that is something that absolutely needs to be addressed, and I would agree with that.
That's why I was asking you how long you've been around when you took the domain name.
Yeah.
Back then, I mean, it was desktop.
Yes, and
Back then it was mobile.
right, and sort of the technical debt of working backwards towards a mobile-first solution is more difficult than it seems, for sure. You can't necessarily use the same kind of strategies on desktop and mobile and vice versa. Yes, I would definitely say that that's going to be changing soon, our entire mobile strategy. It's just a function of, because we're a small company, we can't necessarily throw infinite amount of resources at it. So it isn't.
That's
Yeah.
great, but it's really mobile first.
Yes, it should be.
Got the numbers.
Yeah.
There's no such a thing like
Yeah, for us, it flipped right around October this year is when it flipped. Last year, this time was probably something like 60-40 desktop. Now it's probably something closer to 40-60.
oh yeah, it's dropping.
Yeah, no, yeah, I mean, that's the way it's going for sure.
Game, and I'm not gonna have my laptop there.
Yeah.
I think I should think mobile first.
We are.
One more question.
Yeah. She had a question right there. Yeah, good.
So I'm just wondering how you guys account for like environmental factors and things like that that might not be captured in the database. So like if it's snowing at a football game.
Yeah, whether we can control, I mean, that sounds weird. Whether we can adjust for it. There's human factors which are next to impossible to do. There's situations where if a player is unhappy with his coach or he's hungover, like J.R. Smith with the Knicks, we can't really control for that. I mean, like, you can do it. Yeah, I mean, the stuff you can't control, you can control. The human side of it is difficult to get your head around. It really isn't affected that much. It's like a plus or minus of maybe a percentage or two. But there isn't really a great way to handle that sort of thing. I mean, how am I going to know if Blake Griffin didn't get enough sleep last night? You know, it's tough. But all you can really do is the best you can, and that's really the end of it. That's a good question, though.